So if I take this, what would be the opposites of subtracting 1 and adding 3 and dividing by 3? Multiply by 3, you have to do the opposite in the opposite order. Okay? So this would be, we'll go through how you actually find out the algebraic inverse. But if I were to take 7 in here, right? 7 minus 1 is 6 divided by 3 gives you 2. 2 times 3 plus 1 gives you about what? 7. So this is most likely an inverse, right? So we're going to try, let's try another number. If I take, I don't know, 11, no, 11 doesn't divide nicely, but I think it would work. Let's find a number that's going to divide by 3. How about 13? So if I take 13, plug it in here, minus 1 gives you 12, I get out 4. If I take 4 in here, 3 times 4 is 12 plus 1 gives you out 13. Okay, so that's the undoing function. It works in the opposite direction too. So if I were to take 7 and plug it in here, what would I get out? 7 times 3 is 22. If I take 22, subtract 1, what do I get? 21 divided by 3, what do I get out? 7. Isn't that cool? Okay, that's an inverse. So it works in both directions. So an inverse works forwards to undo a function, and it works backwards. And it's only an inverse if it works in both directions, if it goes forwards and
so it's equal
backwards.
on both sides?
Whatever you plug in,
It'll come out.
it'll undo whatever you plug into the original function. The inverse undoes that, okay? And whenever you plug in the inverse, the original function will undo that.
So it's not necessarily equal on both sides though? Or is it equal on both sides?
The number you put in and the number you get out after going through both
Yeah, but they're
the
the same.
function and the inverse would be the same. Okay? And so, yeah. And so this is called f of x. Sometimes they call this g of x, but they write this like this a lot. F, whoops, they don't erase it. They write this as f inverse of x. Like this. So this doesn't mean f raised to the negative 1 power. It means the inverse of f of x. If you go to your calculator, okay, I just want to show you, whoops, not that calculator, sorry. Now it's going to load and all that kind of stuff. But, oh, come on. Sorry about that. But if I did, they don't have a y equals button on this, but you have a little button that looks like this. You could actually you could actually find the inverse or graph the inverse of a function using the x to the negative 1 button, which, oh, maybe I'll show you that later, okay? So, but I brought up the wrong calculator, but I don't feel like bringing it up again. So in words, if should I draw a new page, or should I stay on this page? Maybe I'll draw a new page. Okay? F and G. Can you see that? You can see that in green? Oh yeah, that looks better on your screen. F and G are inverses of each other. If and only if. That means it's true in both directions. That's what if and only if means. It doesn't mean, you know, like for sure. It just means it's true backwards and forward. Okay? If and only if f of g of, not like that, f of g of x equals x for all x in the domain of f. And g of f of x is also equal to x for all x in the domain of g. Oh gosh, sorry about that. I should turn off myself. Okay, and that's just kind of words. And you'll see when, so the domain, I'll talk a little bit about this now. The domain of the original function, do you know about domain and range? Domain is the possible x values, y is the possible what? I mean, range is the possible y values, right? And so when you take the inverse of the functions, the domain of the original function becomes the range of the inverse, and vice versa. The range of the inverse is the domain of the original function, which will show you an example of that later on. Okay? So how do you find an inverse? Anyone know? Say I have y equals x cubed. Like some of you, did I go too fast?
Yeah, can you go up a teeny
Can
bit?
I go up a little? I could just, first I have to pause.
Thank you.
Good. Okay, so I forget. Anyway, so to find the inverse, you exchange the x's and y's and solve for y. So in this case, what I'm going to do, so y is the same as f of x, right? You guys know that? And so most of the time they'll be in f of x form, so you have to know that f of x means y, right? And then you switch. You just take the x, you put an x where the y is, and you put a y where the x is. And then you solve for y. How do I solve that for y? How do I get y by itself? Cube root it or raise it to the 1/3 power, which is the same. So I would go the cube root of x is equal to y. Right? So if I cube root that, I get y. And if I cube root that, I get the cube root of y. So the inverse of y equals x cubed is y equals the cube root of x. If I plug 2 into here, what do I get out? If I plug 2 into there, what do I get out? If I plug 8 into here, what do I get out? 2. If I plug in 27 in here, what do I get out? 3. If I plug 3 in here, what do I get out? 27. So does it appear to work in both directions? Okay? Yes. Okay? Now the other thing about inverses, I'm going to try to draw this. I had trouble in the last class. Okay? If I were to graph this curve, okay? Does anyone know what y equals x cubed looks like? You should know what y equals. Yeah, it looks like a sideways S kind of, right? So y equals x cubed kind of, okay, I'm going to stand right here so it's easier for me to draw this way. So y equals x cubed kind of looks like that. Yeah? That's pretty good. Okay? Anyone know what y equals a cube root of x looks like? Y equals x cubed. It kind of goes up also, but like as you plug in bigger numbers, it goes up. It doesn't go up as fast as x cubed. So it kind of looks like this, except it goes kind of slower. So over here, it actually kind of goes like this. Okay. And over, ooh, I'm doing such a good job over here. Okay. And over here, it kind of goes like, oh, I did much better in this class. Okay. So this is y equals the cube root of x. And this is y equals x cubed. What do you notice about those two graphs? They're kind of symmetric, but they're symmetric about a line. What line are they symmetric about?
Y equals x.
Very nice. Did you know that from before?
No.
Very good. So if I were to graph the line, let's see if I could do this. Y equals x. Y, that's not very good. That's, but I can fix it. Watch. That's right. So anyway, if this is the line y equals x, a function and its inverse are reflections about the line y equals x, because you're interchanging the y's and the x's, right? And so a lot of times they'll say, here's a function, I don't know, like this. What's its inverse look like? And they won't give you an equation or anything. But what you have to do is kind of try to reflect what would this look like over the line y equals x? Well, it might look like something like that. See? Okay? So you could just do it by, the other thing that's true, if the point 2, 8 is on this curve, what's going to be on this curve? 8, comma 2, right? If the point 1, 1 is on this curve, what's on the other one? 1, 1. So they both go through 1, 1, right? They both also go through, these ones both go through negative 1, negative 1. If the point negative 27, what's the cube root of negative 27? 3. Negative 3. So what point would have to be on this curve? Negative 3, negative 27. See the way that works? So if you know points on the original function, all you do is flip them around and you'll find points on the inverse. Okay? So you just, like that, just flip them. Easy? Yeah? All right. So switch places to the x and y. Let's talk about that. So the only problem with function is not all functions have an inverse. Okay? So where's my new page? Do you need a different color? What color do you want?
Purple.
Oh, teal. Is that teal? Okay. Okay. So so in order for a function, let's see how this looks when it doesn't. Oh, that's pretty. I've never used this color before. Okay. In order for a function. For a function to have an inverse, it must be 1 to 1. It must be 1 to 1. And what 1 to 1 means is for every x value, there is exactly one y value. And for every y value, there's exactly one x value. So a function, for every x value, there's exactly one y value. Okay? So, for instance, here's a function. Would you agree that this is a function? I'm really liking this teal here. Is this a function?
Yes.
For every x value, is there exactly one y value?
Yeah.
Yes. Does it pass the vertical line test?
Yes.
For every y value, is there exactly one x value? No, because I could do a, so what you do when you're checking to see if something has an inverse, you must pass the horizontal line test. Horizontal line test. Just the horizontal line test. Okay, so like that cubic function, it passed the horizontal line test because for every x there's exactly one. So this would not, because if I did draw it in the graph, let me do a dotted line so you can see what I'm talking about. So if I were to graph y equals x, here's y, let's pretend that this is y equals x, and I reflect this graph around the line y equals x, okay, in a different color, it would look something like, it would look like a sideways parabola. Is this sideways parabola a function? No. So even though this is a function, its inverse would not be a function. So what you'd have to do in order to get an inverse, you'd have to say, well, I only want this part of the parabola. Then I would only get this. So if I just graph this part of the parabola, I'd say x is greater than or equals 0. Then I would get its inverse would just have this half as its inverse. Okay, so you can do that. You can restrict the domain of a function, and that way you will get a function when you try to find its inverse. Yes, Delaney?
For the horizontal line test, how do you, can you just show?
Show the horizontal line test?
Yeah, I just wanted to know what it's
All I do is I take a line and go like that. If you do a horizontal line and it crosses this function in two places, then it doesn't have an inverse.
So that doesn't have an inverse?
That does not have an inverse.
Uh-oh.
But if I were to erase this half of it, right,
That
but
has an inverse.
then it would pass the horizontal line, right? So then it would have an inverse. Right? Okay, so basically it can't go down and up like that. So, okay, let's undo what I just did because that looks messy. All right, so that's it. So finding, we talked about finding an inverse algebraically. We did that already, okay? And then this is kind of the last little thing. Find the inverse. Find the inverse in this. Find the inverse and its domain. Its domain, and sometimes they'll ask you the range. Domain and range. For, I'm just going to call it f of x. Let's call it y instead of x. Y equals x minus 4. X minus 4 over x plus 2. This is called a rational function. You know about rational function? Function over functions. I think next chapter is all about rational functions. Okay? What do I do first if I want to find the inverse?
Switch it.
Switch the x and y. So I'm going to get x equals y minus 4 over y plus 2. Now what? Yeah, so this is going to be tricky. So I'm going to multiply both sides by y plus 2. Good. Y plus 2, y plus 2. And yes, this will go away, but now I have this times this. And I have to distribute that through. Okay? So I'm going to distribute this, and I write better from this side. Y, xy, x times y, right? Plus 2x equals y minus 4. Yeah? Now, how do you solve that for y? Anyone know? Okay. This is where it gets kind of tricky. Anyone know how to get y by itself? I'd leave the 4 by itself. Leave the 4 by itself. So what you want to do is, here's the trick. Get all terms with y on one side. And everything else on the other. So if I did that, I could hide this, okay? So if I did that, I'm going to bring the y over here, x, y, minus y, equals what? Minus 2x minus 4. I don't need to show the steps for that, do I? You guys see what I did? Subtracted y from both sides and subtracted 2x from both sides. And now, the reason I did this, because now what I could do, here's what people don't know what to do. I don't know how to do this. I have an x, y, and a y. What could I do? Yeah, factor, very good. Yeah, divide, but yeah, first I'm going to pull out a y from both of these, right? So I have y times x minus what? 1 equals minus 2x minus 4. Now I can divide both sides by x minus 1, and I get y equals negative 2x minus 4 over x minus 1. Right? And that's the inverse. Let's pick a number that might work in here. Let's see if it, so, oh, the other thing, sorry, my wrist keeps hurting, okay? The other thing that they do, this would be fine, but probably in the book, what they do is they multiply this by negative 1 over negative 1. And the reason they do that is to make it look a little bit prettier. Because if I multiply this by -1 over -1, I get y equals positive 2x plus 4. -1 times x gives you negative x. And -1 times -1 gives you positive 1. So I could write this as 2x plus 4 over 1 minus x, which is a little bit nicer than this form up here. See that? Okay. So let's pick a number that will work in here. What's a number that might work? 3? Is 3? 3 work? I don't like fraction. Is that going to give me a fraction? -1/5. Oh, that's going to give me an ugly fraction. What if I picked
2.
10? No, that's going to give me a fraction too. 2? Let's try it. Yeah, that give you 1/2. 8? Does that work? Okay, let's just pick a number and see if it works. Okay. So let's take 8. Why not? If I plug an 8 in here, I get 4 over 10, right? What's 4 over 10? 2/5. Okay. So then I have to multiply 2 times 2/5. I'm just going to do it in my head. 4/5, right? Plus 4 over 1 minus 2/5. You know, I just want to see if it works. That's 20/5, 24/5 over 5/5. 24/5 over 5/5. No, over 3/5. 3/5. The 5's cancel out. I get 24 over 3, which is what? 8. I just did that kind of. That's kind of math in your head stuff. But it does work, okay? So that's the inverse. Find its domain and range. What's the domain of this function? What can x not be equal to? X is not equal to 1 in the inverse. And all you have to do to find its range, like some of you guys might know how to find the range of this, but all you have to do is look at the domain of this function. What's the domain of this function? -2. Y is not equal to -2 would be the range of the inverse, okay? Because that's the domain of the original function. So the domain and the range switch. If I were to graph this function, just to kind of, this one, let's see. If I were to graph this function, I don't know what it is. It has an asymptote at 1. It has another asymptote at -2. So I think what it might look like is it either looks like this or it's going the other way. Okay? But the range is x can never be equal to -2 and x could never be equal to 1. But if I graph it, I think it's either going this way or it starts up here and goes there. So anyway, and the other one looks like a flip of that over the line y equals x. So that's it. We're done. How long did I talk for? 23 minutes. That's